Welcome to What Is It About the Weather, a podcast where we explore the many ways that weather intertwines itself into our lives. I'm your host, Mark Jelinek. This week, we're going to be talking about tiny weather. How tiny is your weather? We always talk about large stuff, so we'll get back to that. In the origin story, maybe. I hope you're doing well in this, what I would call variable weather season. I've certainly been having a lot. Some days we're having to run the air conditioning. Some days where I'm having to curl up under a good blanket, wake up in the morning just to feel motivated to get out of bed. But I like that. I like that change of pace, if you will. The seasons that, even within a day, right? Same day, you may go from, I don't know, again, wearing a coat and heavier clothes to being out and comfortable in shorts and a t-shirt. Now, it can make things interesting if you're trying to plan to do something, but, for me, I like that sort of challenge. Now, last week I mentioned Patreon briefly, and I did say that I wanted to recognize a couple folks, and I do. There are some patrons that came on this summer before I got back to even taking the Patreon feed charging system live again. But to both Aaron and Craig, thank you, and it's appreciated. I know we're in a tricky time, and not everybody's got the spare change to be throwing around, and their support, along with others that have been around a while, quite often is substantial, and it does make a difference for me to be able to keep equipment up, keep the hosting going, all those sort of things. So thanks to both of you. And Aaron even actually wrote a nice email in the last couple of weeks responding to the coffee episode where he talked about, different types of weather he likes in different situations, and that was kind of interesting. And some of those were ones that I knew. We were talking about tin roof rain and stuff like that. So thank you, Aaron, for sharing that. And for those of you, this gets back to the same thing with Patreon. I appreciate that monetary support. It does make a difference for the podcast. But just hearing from you sometimes, a quick email, something on Twitter, whatever it is a reminder that folks are enjoying. And it doesn't always have to be enjoying, but just whatever you like to share. Sometimes people share thoughts about an episode. Some people may just share something interesting they came across. And as always, if anybody's got an idea for a future episode or things like that, I always like hearing and getting that feedback, because while I'm living in the weather and thinking about the weather, it's not always convenient, right, to be doing all these things at once. And so getting that kind of refresher from you is sometimes, it just, in a day when I'm focused on other things, it's a nice kind of moment to reflect and go, yeah, it's good to hear that. That's a good idea. And it can be a good distraction, if nothing else, for me sometimes. So thanks again for everybody who supported the podcast, whether it's been monetary or with ideas or feedback or just saying hello. I noticed that I've got a couple people on Twitter that are pretty good about retweeting and liking the tweets. So every little bit helps. And every little bit, like I said, is just, it's a validation of what's going on. And sometimes that can be particularly important. Now, this show is a couple of days later than normal. And the reason for that is I went to record on my normal recording day, which currently is on Friday. I actually do like to do the recording and the edits kind of in the same day and push out the episode. That's varied over time, which is, again, one of the reasons I've never gone to a schedule that is where I can sit down and do everything live with everybody. Still a goal of mine, not quite there yet. But this week there was just a lot of things going on where I was, and I wasn't able to record. But there's a benefit to that. So the next morning, I already knew I was going to be doing some cycling, right? I was going to go out, do a ride. And my experiences on that ride were very related to what we're going to be talking about today. So we'll come back to that. But let's talk about tiny weather, all right? We always, as I mentioned earlier, we always think big. You hear me talking about tropical cyclones, these big, massive events, or we talk about large-scale influences so often. Now, a lot of times we bring that down to a personal level, but when we think about weather, we think about this grandiose thing that's going on around us. But really, weather, like so many things in our lives, and particularly in a year like this where we're talking about tiny little virus molecules so often, weather is equally as small. Weather's a tiny little thing. And one example of that, you've heard me mention before chaos theory, or this idea of little things turning into big things in a cascading sort of style, that it can take a small little effect at the right point, at the right time, can have a huge implication. So it impacts the theory of weather and weather forecasting, but even at a molecular level, weather is, at its core, that's what it is, right? A primary element of weather that we think about, because sometimes, when you think about like temperature or wind, you can relate to those, but it's not something that is necessarily easy to grasp, because it's this sort of thing that's going on around us, right? We don't have individual pieces we can hold on to, but water changes that, right? Water's something that's a quintessential element of our lives, and it's a key element of weather, the weather we feel, the weather we experience. And those simple H2O molecules, a couple hydrogen atoms, a little bit of oxygen thrown in there, and it's a fundamental aspect of what weather is to most of us. Not everywhere. A lot of places in dry, arid climates, you don't think about the water that much. You may think about it from needing water if you're out in the sun too long in a dry climate. So in that way, I guess it comes back to water in the end. But water being such a key part of us as humans, but it's also a key part of weather and what drives weather. The way we even experience or feel weather. So we talk about temperatures a lot of times, but when you talk about things like, heat indexes, or, you've heard these global wet bulb things that have become really popular with sports, where the level of moisture in the air, or H2O, is a very key element. And it happens, we're going to look at it at both ends of the cycle, right? From its beginning, so getting water to us, that water piece of getting water to where we are, as well as the other side of things, once the water comes down, some of the impacts it can have. But when you think about the water that ends up in the air around us, not surprisingly, the vast majority of that comes from ocean-based sources. Now, if you live near, an example that's not like that, I lived in Syracuse, New York, example, and a common thing in the wintertime was lake effect snows. And it's a reminder that you don't have to have a huge body of water. I mean, the lake that fed it is sizable, but not ocean size. That can have a localized effect. But when you think about moisture on a grand scale, and for instance here in the U.S., east of the kind of the Mississippi River, almost all of our moisture that we get that falls out, or a great deal of it, comes from the Gulf of Mexico. It's fed up from the Gulf of Mexico. It's this abundant flow that comes into the southern U.S. and is transported. Some of it also comes from the Pacific, all right? But around the globe in general, the vast majority of water that ends up on land, well, and of course over the oceans, is coming from the oceans, all right? But what you didn't maybe know or realize is that for us to get raindrops or snowflakes or those sort of things, the water has to condense around other molecules. It's not just the H2O that becomes critical. So for us to receive the water down at ground level, water has to condense. When it's in vapor stage, it's not condensed. It's existing in a gas. Right? Going along doing its thing. But when it has to condense, it usually condenses around, it doesn't always, but most efficiently it does around other things. And you may have heard about cloud seeding before, where they've tried to make it rain in places and those sort of things. And we've used different sources that will allow those H2O molecules to condense easily. But what we're finding more and more is the best material to condense around is things that have a similar structure of water, this kind of lattice framework to it. And interestingly, it's not using something like a particular metal or a pure element. It's more organic materials or fragments of organic materials that work best. So think of water as being, it likes organic too. Big organic food craze right now, right? So water likes organic. And one of the best sources, some recent research is finding, is the waves. So as waves churn around and come ashore, or even in open ocean areas where you get, strong wave activity, the breaking activity, kind of the splashing around, if you will, kicks up and breaks up organic material near the surface of the ocean. And that can be things like plant material, like kelp or something like that. It can be other, any sort of small life. And again, we get back to tiny, and in particular, plankton is an example of that. And so as the plankton is kicked up in the air or broken up and dispersed into the air, that stuff, just like water vapor, is going to flow higher into the atmosphere and flows all the same places that the water vapor does. And it's actually that organic material, interestingly enough, that makes some of the best condensation sources for water. Now, there's a flip side to that, though, is just having stuff kicked up in the air, and it doesn't matter, what's being kicked up in the air. If you don't have enough moisture, or if you're not getting clouds in general, you're not getting to that source, it's not gonna matter. So you still need abundant moisture, and you still need temperature changes and the other things that drive condensation. And some of that's going to happen the higher up you go, right? Anyways, in the atmosphere, it makes it easier to condense conceptually with less moisture, as we know. We've talked about that before, because the atmosphere can just hold less of it. But in any case, you're not going to magically, if you throw a bunch of organic material into the sky, you're not going to magically get rain. But the research pointed out is we've used different things, and I think there's a silver-based one that's been used for cloud seeding in the past. But if we find that actually organic material works better, it may make it easier to do cloud seeding in areas that have been facing drought, right? Again, right conditions. You need the right condition to seed clouds anyways. You can't just magically make them out of nothing. But instead of dumping heavy, metals in the sky and working with things like that, it might be easier to do it with natural organic material that would exist ordinarily in the process anyways. I don't know. So now we got water in the air. Let's just go with that. We got water. We've got these condensation nuclei that the water can adhere to. Falls out. We get rain. We get snow. We get ice. We get whatever it is comes out of the sky. Water comes down to the ground. Now, again, quite often we think about that in big ways, puddles in the road, even if it at a personalized level, that's still pretty big, right? We don't think about individual water molecules necessarily and their impacts. But actually, sometimes the most influential water in terms of our way of life, okay, is when it gets really small. And it goes and it finds cracks in, it can be in concrete, it can be cracks in asphalt, anywhere it can get into. But just think about it, the smaller that water can get, all right, the more it can seep through those individual surfaces. And as somebody who is relocated to a more, let's say, winter weather influence climate, I have been reminded about the influence on roads, and it is meaningful. And so we get to yesterday. I was out on a bike ride, and I was in a park, big state park, and just driving through some roads, and some of them, were in good shape, had been paved, in the last couple of years, let's say, and others were just horrible. And even at points where, I was being jostled around like my bike, and I was, it wasn't a route that I'd ridden before, so I was worried that I was going to get kicked off my bike. I mean, it was kind of that bumpy, and I was, it was interesting because as that was happening to me, I was thinking about, this is exactly what I was talking about, because water that seeps through the ground in a non-cold climate can kind of do so, go about its way, and maybe not have a big influence as it kind of gets back to the water table where it would normally sit. But in climates that get below freezing and do so on a regular basis, or freeze-thaw sort of thing, you have other challenges. So as that water, and this is something that you may be familiar with and maybe you're not, water as it gets cooler tends to contract. And that's not, easily that's kind of, we can kind of get our brain around that because we think of water vapor as being this big open air thing kind of blah, around in the sky. But as we get closer to water drops, or as we get to that water drop stage, and then as that gets colder and colder, we can imagine, because we think about it this way, when you're cold, you almost feel a little smaller, right? But then when it gets very close to freezing, it does something different. It starts to expand again. And then with ice, not surprisingly, it gets a little larger as it gets into that lattice or solid structure. And it, on average, it varies a little bit, again, depending on the nuclei and everything that's going on and what is forming that ice. But more or less, let's say it's somewhere between 5 and 10% it expands. Now, you may not think that's much. But as it freezes, that freezing change from when it was a liquid form, let's say it's in the road, can actually create pressures in the tens of thousands of pounds per square inch, which is a standard measure. I'm not going to try to, that's one we all know with tires and stuff. Maybe you use other metrics, but that's still a pretty common phrase. So I'm not going to go metric on you today. But just imagine, you think about a tire. So a tire, a standard tire, you might be somewhere between, 35 and, 50, let's say, on your pounds per square inch when you're driving down the road, right? But what about, when this little bit of ice freezes? Think about it. If instead of being 30, let's say it's 30, your tires use 30, my bike tires use 60, whatever it is. But imagine 30,000 pounds per square inch, all right? It can create up to 30,000, not 30, 30,000. So it's a vastly different thing. And then you start to realize, wow, what could that really do to the roads? Well, it can have a huge impact. And it can have a one-time impact where it kind of pops something out, particularly, and this is why you might see it where seams come together, like they pave multiple lanes. Well, where that gap comes together, it's two surfaces that weren't laid at the same time. So there's probably a little variance there. But it's not just there. It can happen anywhere. And so once it gets started, it makes it easier to pop off additional pieces, right? That's why potholes can grow. Yeah, it grows from us driving through it, knocking off pieces as well. But just the weather itself can drive that. The challenge is it's not just within the road structure itself where the problem can happen. So as that water even seeps beneath the road, it can do the same thing. So it gets beneath the road, it's sitting there in a liquid form, and then it freezes again. And it can pop up into that road and do it from below. But it can also break up what's underneath the road. And as it does that, it can create a sinking effect as that expansion goes away. So all this up and down jostling just makes it miserable for the road. And that's why roads give way over time. Right? It doesn't matter whether it's asphalt or concrete. And actually, one of the benefits of asphalt is it does have a little bit of a flexibility component to it in the surface. Yes, it's all pressed there. But if you've ever looked at asphalt, you kind of notice it's kind of an uneven surface. So it has a little more flexibility, like I was saying, than hard concrete does, which you think of as being a block. And so once that block, for instance, if some of the surface gave way underneath, it's eventually going to give. Now, it may be a stronger solid surface, but if you think about sinkholes, and we've all heard of them, if enough stuff washes away underneath, that'll happen. And again, water underneath, once it's beneath that surface, if enough is flowing underneath, it can wash it out. The ground washes out underneath, you're going to get a sinkhole. So it's very real, and that's one of the ways, even at a tiny level, those little water molecules get through the road and do the freeze and thaw, and voila, just like that, it has a major impact. Tiny weather. Starts tiny, finishes tiny, but it has major implications in the meantime. I don't know, just a little food for thought. I thought it was kind of interesting how when you think about water, and again, we think about these huge storm systems, winter storms, tropical cyclones, and we always think about the large, grandiose impacts. But you may have a road just near you that suffers major winter weather influences just because of tiny, tiny, tiny little water molecules. And enough tiny little water molecules going from liquid to solid, liquid to solid, liquid to solid will eventually break up a road. And then stuff, you see this kind of portrayed in sci-fi movies. And actually, I've got a parking lot near me that's a prime example of that, where grass has started to grow in between it. Doesn't take very long. Once there's a little bit of space, then the roots get in there and they do their thing, and every little bit continues to crack up, and break things up. Things start small. Little powerful forces turn into big powerful forces, and weather is a prime example of that. One of the interesting things, and I'll close with this, is I was reading about plankton. I was talking about a source. Plankton also play a key role in carbon. And I know there's a lot of people that are very concerned about where the climate on the earth is going. So this little tidbit you can walk away with and read a little bit more about it. Plankton themselves play a big role in the carbon cycle and the role they play in the oceans. But what we're finding out is we don't really understand it as well as we maybe thought we did, or we're learning new things about the role carbon will play in dispersing carbon, because the oceans are where a lot of carbon goes to what we call a carbon sink. So it takes it in and puts it down in the depths, all right? So it pulls it out of the atmosphere. But the role plankton play, we always thought was one thing, and it might be another in terms of regulating how much carbon is actually in the atmosphere. Something to keep an eye on. But I think I put a little link in the show notes about how plankton growth is influencing where we are with carbon dioxide. And we may actually see a lot more plankton in the ocean if we continue to see higher levels of carbon dioxide in the atmosphere. All right. I'm going to let you guys go. I'm going to let you enjoy your fall weather. As always, think of things when you're out there. Enjoy things, enjoy the weather, but, maybe put your mind around a little piece of weather element. And then, if you're thinking about it, pop me an email. What is it about the weather at gmail.com, or what is about the weather on Twitter? Let me know what you came across, what aha moments you had. Because as we all know, there's much more to weather than the weather itself.